Good morning. We'll get started with chapter 5, which is on estimating project times and costs. So we have completed chapter 1 and chapter 4. Now we'll get started with chapter 5, which is on estimate. So there is a sequence in which the chapters are connected with one another. Estimating a project is needed so that both the stakeholder and the project manager can understand what is the approximate cost of the project. It also estimating a project can be uh, estimate like projecting the cost and also the time. The estimation can be done by the top-down approach and the bottom-up approach. In the top-down approach, we try to find out what is the cost of similar project done elsewhere, or maybe develop a mathematical relationship by which we understand. Again a macro level estimate. Uh, it's not very detailed, by which you understand the overall cost of the project. So this is the top-down approach. The bottom-up approach, which is more detailed, where we try to estimate cost of individual elements, we add it up and then arrive at the final cost of the project. When a project manager wants to get into a detailed estimate, he always tries to uh, go for the micro estimate or the bottom up approach, where it gives him more specific cost of individual items. Now, why do we at all take this trouble of estimating the time and cost? One reason might be it supports good decision about that project. It helps us to schedule the work uh, when each of those work should be done. So it is the scheduling can be done based on the estimate. It determines the how long the project should take and how much should be the cost. In that way, they can arrange for funding which would be required to run the project. Uh, that is also called the cash flow need, when the cash flows are needed to implement the project. The estimation helps to understand how well the project is progressing. If there is a delay, you'll be able to make out that, well, there is some delay, and there is a necessity to speed up certain process. To develop time phased budgets uh, and establish the project baseline. This enables the project team to develop when they place the budget to the clients, they can do it time phase wise. Like a project is total duration is a year, so maybe they can have a quarterly budget. Okay, and they can understand based of that the payment will be done. Now, the factors which influence the quality of estimate is the planning horizon. If the planning horizon is for a short period, the estimation is more accurate. But if it's for a long horizon, it tends to have more error in it. That's because the longer the horizon, the chances of uncertain factors getting in uh, is possible. Or maybe it's the project team is not able to see all the unforeseen cost if the planning horizon is too long. Project duration, again, if the project duration is long, the estimation is loses its accuracy. People uh, people factor is important. For example, if there is a close match of people skill to the task
it will increase the productivity, and the estimation would be accurate. So if you have the right people, the estimation would be accurate. If you don't get the right people, the estimation might go wrong, because it might take longer time and it might need more cost. Project structure and organization, that also have an influence on the estimation. Say if you have a dedicated team for the project, then the estimation would be more accurate. On the other hand, if it is a matrix environment where the same set of people is shared by different projects, in that case, the cost might be low, but the time frame might vary. So in that case, the project may not be that accurate. Padding estimate is when you add some extra cushion. You basically mm, estimating guidelines for times, cost, and resources. Now, these are some of the guidelines which can be followed while making the estimate. So the first one says that the people who are familiar with the project should be involved in the estimation process. So people who are familiar with the project or each of the tasks of the project should be assigned this responsibility. Use several people to make estimate. If several people are involved, then their collective knowledge improve the estimation accuracy. So some might be little on the higher side, some might be on the lower side, but that pooled knowledge is always better. Estimate on normal condition. So when you are making the estimate, don't be working condition. Now, as I mentioned before, there are two type of estimates. One is top down and other is bottom up. Top down is usually done by someone who is experienced in the project. Usually the top management who has an overall understanding of that project would be doing the top down estimate, are made by the top management who have little knowledge of the processes used to complete the project. They have a macro level view of the process or macro level view of the project. So they don't go into each process level. Okay. On the contrary, in the bottom-up approach, they will go to the process level. So the bottom-up approach starts with the WBS, work breakdown structure, where the whole project is broken down into individual works or process, and each of those are estimated, and finally it is rolled up to get the total project cost. So when do we use the top down and when do we use the bottom up estimation or estimating? For strategic decision making. So top management is making some strategic decision. They will go for a macro level estimate. They don't need detailed estimate at that stage or for that strategic decision. But when cost and time are important, they'll be going for the micro estimate, because that exact number of days is required, or exact number of working weeks are required. Highly uncertain. If the project is highly uncertain, we don't know whether the project will happen or not. In that case, it's no point spending time and manpower to do a detailed estimate, which is micro level. So they'll be going for the macro estimate. If it's an internal small project, it doesn't really matter whether the time varies or the cost varies a little bit. That's fine. So they will go for the macro estimate. Then there is a fixed price contract. Say you are submitting a bid and it is a fixed price contract and you cannot make changes in the future. So in that case, the project team will be going for the micro estimate because it has to be detailed. There shouldn't be any mistake. If you leave certain portion of the project, then you might not get paid for that. So you have to include everything which is part of that project. Customer wants details. Say the client to whom the project estimation is being submitted, he wants a detailed estimate. So in that case, a micro estimation would be required. But if the scope is uncertain, you really don't know what would be the extent of the project. In that case, you cannot go to that micro estimate. You have to be satisfied with a macro estimate. So what is the preferred approach? Before you go into the micro estimate, you should make a macro estimate so you know overall what would be the time and the cost. So that's done initially so that you can get an overall understanding. After that, the project is break down into smaller packages, okay, using the work breakdown structure or task. So each of those are individual tasks. You can, if it is rolled up, it goes up to the project level. If it is rolled down, it goes into individual task level. So after the WBS and the organization breakdown structure is done, you go for the bottom up estimate, the micro estimate. So based on that, the schedule and the budget would be done. And finally, you'll try to compare those two, the micro estimate which was initially done, the macro estimate which was initially done and the micro estimate which is done later, and try to understand why is the difference, or if there is any difference at all. So what are the different strategies of or different approaches of this macro estimate or top-down estimate? One would be the consensus method. So in the consensus method, is more like the Delphi technique, where experts, the expert opinions are taken into consideration to make that estimate. The next approach would be the ratio estimate. So you can estimate a 1,000 square feet building. If it is 2,000, the cost would be doubled. So, or if the area is tripled, the cost will also triple. So this is called the ratio estimate. It is, say if you know the per square feet cost, you'll multiply the per square feet cost by the number of square feet. Next, there is the apportion method, where each of the tasks are given a particular ratio, like making a, say, a IT project. It can be divided into a number of tasks like design, program, test, document, produce CD, and each of them will have a specific percentage, like design maybe 20% and program maybe 30%, and based on that the estimation is done. For software projects, they use a technique which is called the function point technique. Based on how many function points are there, the estimation is done. Function point includes things like how many inputs are required in that program, how many outputs are required, how many inquiries are required, files are required, and interfaces are required. So based on that, the estimation will be done. Then comes the learning curve. When a labor is put into some work, initially his productivity is low, and slowly as the project progresses, his productivity increases. So that learning curve is taken into consideration in project estimation. So this is a typical example of a the allocation method, where the project is divided into these 5 major tasks, and each of them has a specific percentage, like design, program, test, document, product CD, and if you know the cost of each of those, the other can be determined. This is an example of how the function point estimation is done. So as I said before, the function points are number of inputs, number of outputs, number of inquiries required. Again, these are the requirements of a software project, okay, or a IT project. So how many inputs are required? Inputs may be from the users. How many outputs are required by the users? What type of queries can be done? How many files would be used? Number of interfaces. Now in this slide we see that each of those inputs are given a different weightage. Like the input is because its complexity is low, it's given a weightage of 2, whereas the file is given a weightage of 12. So if you multiply the total number of inputs with the weightage, you will get the total score. So in that way, if you add it up, you get to that number 660. In the bottom-up approach, we can use the template method, which is based on past experience. So you develop a template, like for making a brickwork, these many workers are required, or this much of material is required. So you have those known facts from the previous experience, and you are using those to do the estimation. In the parametric method, it's very similar to the ratio technique which we have seen in the top-down approach. So for each task, you use a parametric process, something like the square footage for estimating the building cost. In the work breakdown, we can use some range. So range can be, say, piece of work can vary. It can be done in 5 days to 10 days. So 5 days is one extreme, which is a low estimate. 10 days is a high estimate, and it can be somewhere in between. So in the WBS we can do that range for each of those tasks. And phase estimating or a hybrid technique. So initially when the project starts, we can start with a top-down approach, but as the project progresses, as we get into more details of the project, we can go into the bottom-up approach. So this table shows, which is again done in Excel, it shows for the WBS we can have a range. We have a low estimate, we have an average estimate, we have a high estimate, and the F row over there shows the range of days, the difference between the high and the low. This is the phased estimation technique, which is also called the hybrid technique. So in the phase 1, when the project just gets started or before it starts, we do a macro estimate because we don't have detailed information of the project. But as it progresses in phase 2 and phase 3, we get into more detailed estimate, the top down or the macro estimate. So again, detailed for a specific task, like for the specification. In the phase 2 we know about the specification, so we can go a detailed estimate for that, but for the design, production and delivery we don't have any understanding. We go for the macro estimate or the top down estimate. In the phase 3 we get understanding of the design, so we know what the design would be like, so we'll be going for detailed estimate for it, and for the rest it would be macro. In phase 5 we'll go for detail for all of those because we have understanding of all of those now. This table shows what are the a comparison between the top down and the bottom up. So where the top down would be used, we have discussed it, and where bottom up would be used. What is the preparation cost? Preparation cost for the top down is much less compared to that of the bottom up. Bottom up is more detailed. Accuracy, the top down is less accurate. It ranges from -20 to +20, whereas the bottom up is more accurate. It goes from -10 to +30. So that means if I can just do a sketch here, let me take a pen. So if this is the actual, the top down can go up to 20% less or 60% more, whereas the bottom up, if this is the mean, the center is the mean or the actual cost, it can go on the lower side like 10% and the higher side 30%. So it's more accurate. And what are the different methods which are used for each of those techniques? And we have discussed that before. The level of details. Different level of the management will require different level of details for the project. Like top management will not need that detailed information about the project. The middle management maybe require for a specific project, they need some more information, more detailed than the top management. And the bottom management, who are assigned with a specific task, will require really detailed message. WBS, what we have seen in the previous chapter, it has got different levels: level 1, to level 5 maybe, or it can go even further down. So level 1 would be for the top management, level 3 maybe for the middle, level 4, 5 for the bottom management. So as we move down, the WBS, the level of details increases, and those detailed level of information is needed for the bottom management. Now one should understand excessive details is costly. It's expensive to calculate, but insufficient details is costly as well. We might leave out certain items. We might make some vital mistake as far as time and cost is concerned. So there has to be a fine balance, like how much time and effort we will dedicate for the estimate. Now, the type of cost can be classified into three major categories. Direct cost, it would be the cost of the labor, material, equipment which are specific for the project. So that's the direct cost. We have direct overhead cost, which are the salaries and the rents and supplies, which are required for the particular project. So direct project overhead cost. Next is general administrative overhead cost, which is needed for the organization. It is not specifically for a project. So overhead is differentiated into project overhead and general and administrative overhead. A certain percentage of the general or administrative overhead, it is allocated for a project, because project has to bear some of those costs. So over here we see that the direct cost is 80,000, the overhead cost project is 20,000. So the total direct cost is 100,000. Now the general and the administrative overhead cost, a certain part of that is allocated for the project. So 20% of that overhead cost is allocated for the project, so it is 20,000. So if you add all those, you have that 120,000, which is the project cost. And on the top of that we add 20% for the profit. If you sum those two, we get the bid. So this is the amount we are bidding for the project. If we can get a contract for that 144,000, then we will tentatively make a profit of 20%. Now obviously there can be some error. It can be on the higher side, it can be on the lower side. Now these are the three view of the cost. We have the one in between, which is the schedule budget. It is the one over here. Let me take a pen here. The one over here is the schedule budget. Okay. We have a committed budget. So the committed budget is higher than the actual budget. They wanted to keep a cushion. Okay, if I draw a line over here, so there is some cushion over there. Okay, so this is the cushion, and the actual is below that. So the actual is below the scheduled budget, so that's good. So it's not exceeding the budget, and the committed was more. So that is a level of safety in that estimation, in that cost estimation. Now refining estimates. Reason for adjusting estimate creating a database for estimating. Most companies, they create a database for estimate, like say they're estimating uh, a database, how much it will cost to build up a database. It will have some MIS components, some hardware components, some programming component, production component. So they create a database for each of those tasks from their previous projects. So based on that, on the past record, this they update those based on the requirement, and then come up with a estimated estimate for the project. Now these are the key terms which we have dealt with in this project. This figure shows a WBS. This is the level 1. We have level 2, 3 and 4. Level 1 would be for the top management, and level 4 is for the bottom management. 2, 3 would be for the middle management. So as we go down the WBS from level 1 to level 4, the level of details increases. Now the top management doesn't require that detailed information. They're happy with what they get from the level 1. Learning curve. So we have talked about the learning curve. So for the first unit, the time required was 1. So after the first unit is produced, the productivity of the worker increases. So for the second unit, if we consider a 60% learning curve, the time required would be 0.6. So initially the time required for a piece of work was 1 hour. That will come down to 0.6 hour. For the 16th item, it would be 0.1296 hour. So we see that it progressively decreases. Now if we consider an 80% learning curve, so for the 16th item, the time required would be 0.4096. So for the second item it is 0.8. So for the first item it was 1 hour, it decreased to 0.8, then it progressively decreases to 0.4096. So this, please remember, this is for unit values. So this is for that specific item, like the 16th item, what is the time required. Now in the next slide we'll look into the cumulative value, or the cumulative value. Let me go to the next slide. So over here we see the cumulative value. What does it mean? So if I take the same example, for 16 units we require 8.9 units of time. Say if it is hour, if the unit is hour, it is 8.9 hours. So that means for the production of 16 units, the time required would be 8.92. Previously we had taken a look at the unit production, that is for the 16th item production, what is the time required, and now we are looking into the time required for 16 units of production. Okay, so this means total 16 units of production. This is the time required, 8.92. In the previous slide it was for the 16th unit only, but over here we sum up all these. Okay, we sum up the individual time. So these are all cumulative values. So you get this 1.8 by adding 0.8 with 1. So as we go down, we keep on adding those unit values from the previous chart, and we get the cumulative values. So this is the addition of all the unit values from the previous chart. So our chapter 5 ends here. If you have any question, please feel free to send me an email. Thank you.